Okay, we are at start time. So let's begin. All right, I want to first off thank everyone for coming out today. Before we start, before we begin, guys, I want to make sure that I go through some of these housekeeping items. I will be muting everyone to the end of this webinar. If you have any questions, comments, concerns, whatever it is, please use the chat box. We want to know. And for your benefit, this webinar is being recorded. That way you could go ahead and share it with your teammates, or you can review it at a later date and time. So let's get right into it. Introductions. Hello, everybody. I'm Bobby Gimmerath. I'm also known as Bobby G. I'm the partner trainee and development manager here at Access Networks. I've been in this industry, this crazy industry, for several years. I have a lot of friends on this chat room, which I'm really excited about. And I want to kind of explain what we do here at Access Networks. We're the industry leading enterprise network solutions provider for the modern home. And the way that we do that is that we have a design team as well as a support team that are certified both in the AV industry as well as in the IT industry. So let's get into why we're all here today. We're going to talk about best practices, the wireless LAN design and implementation. Oops, go ahead, chat. Sorry, here we go. And one of the things that we want to make sure is that you always want to follow a recommended set of procedures, rules that will give you the best result and that's proven to be effective as well as effective. So in this show, what we're going to do is we're going to showcase how a wide variety of factors can produce the most positive Wi-Fi experience that you could provide for your home owner. So what we're going to talk about on today's agenda is we're going to go over AP selection. We're going to talk about RF propagation. We're going to look at AP placement and installation. And then finally, we're going to show you how to optimize your system by using verification software tools. So when we're looking at AP selection, which access point do you choose? Well, it's pretty easy, right? Everyone has a great answer, but what you want to do is you want to make sure the technology of the access point matches the technology of your client device. Super simple, right? You want to make sure that it provides the highest level of performance. And some of these features, things that you want to think about is the latest Wi-Fi technology. You want to make sure you provide the most available Wi-Fi technology to your homeowner. You want to make sure that the AP is capable of handling a number of client devices that it will connect to. And you want to make sure that AP, your access point, is designed to work with a wireless controller. We'll go more into that. And then you want to ensure that all your APs can be configured for the use of different channels. Super easy to do. You want to make sure it's capable of doing it. And we'll see why. All right, so let's get into generational Wi-Fi. The goal for generational Wi-Fi is to make it easier for the end user to recognize the difference in technology as well as speeds. So as we look at this chart, we're looking at 802.11n. That's everything that we've always talked about, right? And then we have 802.11ac. We always spit out these numbers. And then we have 802.11ax. For the homeowner, they're just like, what are you talking about? So now we have this new naming convention where we could say, hey, Wi-Fi 4, older technology, but it's Wi-Fi 4, Wi-Fi 5, Wi-Fi 6. These generational names allow manufacturers and providers, as well as the end user, right? We want to make sure our end user understands the simple icon of Wi-Fi technology that's contained in their device and how their device will connect to the Wi-Fi network you provide. It's also important to choose APs that are designed to provide the best performance for your client's device. Super easy, right? So how do we do that? With every new network, it should be designed to support Wi-Fi 6 with 5 gigahertz in mind. This Wi-Fi 6 is also known as high efficiency Wi-Fi. Now, here are some of the key features or the benefits of Wi-Fi 6. So you have increased data rates, more robust connections. Wow, that's what I'm talking about. Transmit data to multiple devices. Remember, our last generation, Wi-Fi 5, you can only talk to one device at a time. What? So now we can talk to multiple devices all at once. And We also offer enhanced battery life with Wi-Fi 6. So your current Samsung Note smartphone and your iPhone 11 will have Wi-Fi 6 built into it. And future client devices such as MacBooks, laptops, and tablets will all have Wi-Fi 6 built in. So what makes your access points better? How can you make your access points better? Well, you can introduce enterprise wireless controllers, because we all know there are centralized deployment tools for pro consumer access points. However, enterprise grade access points have a great advantage of having an enterprise grade wireless controller. Now, these wireless controllers will enhance the experience of the access point by actively managing the wireless environment. Now, how does it do it? The wireless controller will dynamically change channels per access point. I'm talking per access point. And this will help fight interference as well as provide analytic tools to adjust performance. It does it for you. So here at Access Networks, we will provide software-based, hardware-based, and now are coming soon, don't tell anyone yet, our cloud-based enterprise wireless controller. Every single one of our solutions will provide a single pane of glass for the entire project. So let's move on to RF propagation. So we're going to talk about coverage area. We're going to talk about RF energy, the building materials, antennas with RF energy, and then the RF channel selection. Remember, we talked about how important RF channel selection is. We'll see why. So let's move into coverage area. As you move further away from your access point, you will have less RF energy. That makes sense, right? So what kind of expectations should you have around the coverage area of each access point? Well, with Wi-Fi 5, your coverage area is 1,500 square feet. That makes sense. But with the new Wi-Fi 6, this is going to require a tighter signal quality than you get with Wi-Fi 5. So with Wi-Fi 6, you want to think about the coverage area being 1,350 square feet when we're designing for 5 gigahertz. And that's going to be less than 40 feet line of sight between the access points. So keep that in mind. Now, how does RF energy travel, right? So RF energy travels at a certain distance. Now, heat maps, site surveys are critical to understand the RF propagation in an environment. So reflective surfaces can reduce, or in some instances, guys, can cause interference. So interior walls, that can give you 2 to 15 dB loss. Doors, depending on the size of the door, the width of the door, the material of the doors, you're looking at 2 to 10 dB loss. That's huge. Floors, 4 to 27 dB loss. Guys, I live here in the state of Florida. We use concrete like it's nobody's business. We are looking at a huge dB loss when you're looking at RF energy traveling through a floor. Now, architectural features such as mirrors and e-glass can produce up to 99% decrease in RF loss energy, right? So I had a client where they were saying, every time I open up the sliding glass door, Bobby, I get great Wi-Fi, but as soon as I close out my sliding glass door, nothing happens because they're utilizing e-glass technology in their sliding glass door. That just kills our RF energy, all right? And then when you're thinking about installing access points for outdoor use, keep in mind, trees and shrubs, that could give you 5 to 20 dB loss every single time. All right, so let's move into building materials, because we kind of touched base with that, right? So what to watch out for? When we're looking at this image, we're looking at this picture. Oh my God, it is absolutely beautiful, right? We have high quality drywall here. We got concrete walls, which looks absolutely gorgeous. Look at that glass door with a metal fixture for the door handles. Oh my gosh, it's beautiful. And then all the brick. Well, for an interior designer, this is a dream come true. But for an RF design engineer, holy cow, this is a nightmare, right? Because RF energy is highly reflective. So if direct signals combines with other signals that are reflected off of these objects, like these surfaces that we see, it can create its own interference. And as we're looking at this image, guys, pro tip, never, never, never place an access point in the hallways. It will kill you. So let's review some of these materials, guys. We've got steel, concrete, radiated heated floors, mirrors. We talked about mirrors earlier, 99% dB loss. We're looking at bodies of water, tile, stone, granite, outside interference, guys. When I say outside interference, these are going to be access points that you did install. They're the neighbors, right? They're the neighbors' access points. So when you're thinking about your design, keep those in mind, all right? And then, of course, interior decorators. Yikes. Okay, so how do antennas affect how RF energy travels, right? So it's never acceptable to mount an AP behind the TV, guys. I just want to throw that in there right now because you have a device that is a TV that is designed to block RF energy, and then you're installing a RF design or RF AP that's designed to produce RF energy. So one of the things that we're going to look at is the most common antenna is going to be the dipole antenna. Now, this antenna transmits RF energy in a donut pattern, right? So in this image I have here, I have one mounted on the ceiling and then one mounted on the wall. So with the best practice, guys, you always want to make sure that you install your access point on the ceiling because of this dipole antenna, the donut shape. It's going to disperse RF energy better than if you're doing a orientation, when you're changing the orientation onto the wall, it's going to change the RF pattern altogether. So keep that in mind when you're designing and implementing a access point in the home. All right, so let's move into RF channel selection. Now, the greatest source of Wi-Fi interference is other Wi-Fi. Let me show you an example of that. In here, if you add an access point in the closet and you design the system to be less than 40 feet line of sight, like I said earlier, which places the next access point in the library, this will give you the correct placement of the access points, right? However, the two APs are now causing co-channel contention. Now, in order for us to combat this, you should have all your APs configured to use different RF channels. And an example of that is 2.4 gigahertz, right? 2.4 gigahertz, we have 11 channels to choose from. Wow, that's great. But guys, think about this. Only 3 are non-overlapping channels. So you're looking at channels 1, 6, and 11 to really be chosen for your placement of your, or designing your access points. You only have channels 1, 6, and 11 to choose from at 20 megahertz channel size, okay? So as we move into 5 gigahertz, you have multiple overlapping channels. And you want to make sure you're designing this to be 80 megahertz channel size. So as we review the 5 gigahertz chart, pro-consumer access points can only use Unity channels 1 and Unity channels 3. So there's no possible way that we can ever get 160 megahertz wide channels to select from because of that. Now, since we want to use 80 megahertz channels, we will only have access to 2 megahertz wide channels, right? So that's what pro-consumer access points. What's even worse is that if you have more than 2 pro-consumer access points, guys, if you're installing more than 2, you will have co-channel contention as well as interference on 5 gigahertz. So the bottom line with pro-consumer access points, you want to use 40 megahertz channels, which is half of what's desired, right? Because I said you want to get 80 megahertz wide channels every single time, so that way you get better throughput. So how do we do this? How do we get more channels? As I said earlier, enterprise-grade access points will always have an advantage over pro-consumer access points. The reason for this is because enterprise-grade access points can unlock the hidden DFS channels. By doing this, enterprise-grade access points can now have up to 6 80 megahertz wide channels. That means the project will need 7 access points before spectral reuse is required for the use of 80 megahertz wide channels, right? So keep in mind earlier when I said enterprise-grade access points can also be tied into enterprise-grade wireless controllers. This will actually go ahead and perform that action for you automatically, which is big. All right, so let's move into access point placement and installation. We're going to talk about proper access point placement we're going to assign location information to each of these access points. And then we want to verify this wireless system works. And we're going to touch a little bit onto infrastructure. So proper access point placement. Earlier I showed you the chart of that donut shaped pattern, right? So you want to make sure that that access point is mounted on the ceiling. It's always best practice to do that. When you're thinking about placing these access points, think about the utility closets, think about the utility rooms, think about you could place these access points into proper enclosures so you could hide them away. Now, omnidirectional or not, we gotta follow the 80-20 rule. And I know what you guys are thinking, Bobby, what's the 80-20 rule? Well, let's get into that. So what the 80-20 rule is that 80% of that RF signal comes from the access point, will come from the front and the sides, right? That makes sense. And only 20% of that RF energy will come from the top. So that's the 80-20% 80-20 rule that we're talking about. So when you're designing this system, remember when I said, hey, if you change the orientation, when will you do that? So some installations like a multi-story dwelling will require that you place these access points in a different orientation, which makes sense. So now you have an access point here, you have an access point on the side, you have the access point over here on this side. But you want to make sure that you always follow the 80-20 rule to ensure proper RF coverage. So let's talk about assigning location information to these access points. Regardless of what AP that you use, it's so important that you take the box that access point came in, right? So if it's in the master bedroom, you're gonna match up the MAC address of that access point to that box, and then you're gonna write down master closet. And then you go to the next access point in that box, you're gonna write library, and then next one, and next one, and next one. And the reason that you wanna do that is that when you're naming these access point into the system, you will understand how you want to get 20% overlap between APs, right? So you have your neighboring access point. You want to understand how that all works, as well as that if there's any kind of troubleshooting that you need to do with those access points, you know exactly where they're placed. All right, so now we have all the access points installed. Yay, this is great. We have them all named. We know where the locations are for these APs. It's time to verify the wireless system. And the reason that we want to verify the system is that it's a given, right? We want to make sure that all APs on this job site are functioning correctly. Now you want to verify the APs, all the different APs are on different channels from each other, right? Because we don't want to battle co-channel contention. We showed you how that's really bad. And then we want to do a Wi-Fi verification site walk. And that basically means you want to traverse as a typical homeowner and walk the path using your handheld device. And you want to stream something like Twitch, or if you're a high usage of Netflix, go ahead and have Netflix playing, right? Because majority of our clients have children, and majority of the children, they never stay in one spot. They don't stay in a chair, they don't stay on the sofa, they like to move around in the room. So you want to pretend that you're that kid, and you want to go ahead and hide underneath the desk, or you want to go into the corner of a room, wherever it is, and you want to make sure that AP is giving you the right amount of RF energy to your client device, so that way you don't get that phone call, because you don't want to receive that phone call from a client. And then if you really want the optimal system of verification, guys, if you want to make sure this system is running exactly the way you designed it, hey, you know what? Perform a Wi-Fi validation site survey. Super easy to do. All right, so we're going to touch a little bit on infrastructure and best practices for infrastructure. So when you're thinking about this, I know you guys are all sitting there like, Bobby, we know this, we get it, we totally understand. I know, it'd be remiss of me not to go through this again with you guys. You want to make sure that all your Ethernet cabling has been certified. So when the guys are going out there to install, they're not troubleshooting the cable. So you want to make sure that it's been certified. So as well as all your access points have proper power. What does that mean? So if you're using an 8x8 access point, you want to make sure your network switch can provide enough high output to power up that 8x8. And you're like, Bobby, oh my God, we forgot our network switch can't do POH. It's okay. Guys, we also have PoE injectors that you can use as well as power adapters. Now, with the wall warts, guys, you got to be a little bit aggressive at making sure that you have power next to that access point so that you can plug it in. And since we're talking about network switches, you want to make sure that your PoE requirements are at 80% or less of the maximum rated of that network switch. Because what you want to do, you want to have 20% headroom in that access point. You don't want to go over it. You don't want to be 85%. You don't want to be 90% of that headroom. You want to be 80% or lower. And speaking of network switches, guys, you want to make sure that all your equipment are located in a room with adequate ventilation, as well as air conditioning, because we want that investment that homeowner made with you to last a long time, because you want them to trust you so that when you're doing a future upgrade, they're like, hey, this guy knows what he's talking about. He made sure that I place these things in a ventilated air conditioned room. And speaking of all that equipment, you want to make sure that it's connected to proper UPS, because you want to be the expert, right? You want them to know that I trust you to provide me the right solution. Integrator X is like, I got you because I'm going to provide you with a UPS. I'm going to make sure your investment is protected by a surge protector. Because the reason I say all this, guys, in the IT world, it's never a question of whether you follow or not follow these guidelines. These guidelines are accepted as minimum. I'm talking minimum system requirements. All right, so let's move into verification software tools, right? Let's talk about the tools that can help you optimize for the best Wi-Fi deployment. Now, when we're looking at this, we have predictive heat maps, we have predictive site surveys, which is AP on a stick, another way of saying it, and then we do validation site surveys. Now, you can use one of these solutions, you can use two of these solutions, or you can use a combination of all three of these solutions. It only helps you to have these tools in your back pocket to pull out anytime to make sure that you're providing the most optimal Wi-Fi deployment. So let's talk about the first one, predictive heat maps. This is a software-based process to predict RF coverage. Now, this process requires known variables such as building scale. A great example of this is the measurement of the longest wall of that building, right? The next thing that you want is what type of building materials are going to be in the home. This is going to be drywall, doors, walls, how thick, and what it's made out of. And once you have all that information, it's going to be inputted into the software, and it's going to provide you with multiple reports types that can be provided for you as well as for your homeowner. So let's look at predictive site surveys. And these are AP on a stick. A predictive site surveys will validate your predictive heat map that you just did before a full site deployment by simulating the access points and the deployment height. That makes sense, right? The use of the access point that's specified. So if you specified at A750 for the project, you want to make sure that it's placed in a permanent location temporarily by the use of a tripod or other mounting solutions. The RF energy is then measured throughout that structure by an expert site survey engineer. That makes sense, right? Now, keep in mind, this process is performed before the final install of all the access points. So let's just say that you measured that location that you thought it should go, and you were like, I'm not getting optimal performance out of that location. Now you can actually move that access point to the optimal location before final install, and this is what you want to do. This is a great tool to use. Now, validation site surveys. The validation site survey, guys, is the point that the project has been completed and the access points are all installed at the specified locations. This is the point the expert site survey engineer will now validate the wireless network by utilizing the hardware and software tools at their disposal. A recording of all the RF measurements are done by walking the property by this expert site survey. And then he or she is going to provide you with multiple reports types to both you as well as your homeowner to validate that system. All right, so let's go and kick on the whole summary. Let's just do a quick recap, guys. AP selection. Like I said, you want to design for Wi-Fi 6 because the AP is the one that matches the technology of your client device. RF propagation, this is the environment as well as the antenna technology that will affect RF energy. And then when you're looking at AP placement and installation, remember, ceiling mount, dome down, naming your APs, doing a verification that the APs are all working. That's what you want to do. And then verification software tools, this only helps optimize the best performance for your physical environment as well as your wireless system. Now, finally, we have the tools to make your lives easier to provide the best performing solution that your clients expect from you. And we have a wide variety of new Wi-Fi 6 access points. We have the new A550, the A650. Those are shipping at the end of this month. Yay! And of course, we still have the A750 now ready to go. We have software-based, hardware-based, and the cloud-based wireless controllers that are available. But at Access Networks, guys, we're more than just hardware products. At Access Networks, we're here to keep you connected. And the reason for that is our people, our team. We have a design team. We have certified IT engineers that are here to support your deployments. We have the client services team. That's going to be the guys that are out there selling the stuff. Those are going to be the people that are inputting your sales orders, the design team, as well as us, the actual trainers. We're all part of the client services team. We're here for you, and we want to help. So I want to thank everyone again for coming in, doing this presentation with me. And if you have any questions, let's go. Any questions?
Hey, Bobby, there was a question about the DFS reserved channels.
Sure.
And the question was, can we implement those or utilize those DFS reserve channels with Access Networks deployed devices?
We do. We actually do that now. So in the past with Wi-Fi 5, we didn't really do that a whole much. We actually just made it so that it was in performance mode, meaning that the older technology like Wi-Fi 3, Wi-Fi 2, and as well as Wi-Fi 4 all worked properly. But now as newer technologies are coming out with IoT, we can see that we can actually put this in a different mode that actually unlocks the DFS channels. And we're doing that now with the deployment of our hardware-based C120 wireless controller. So yes.
Yeah, the key foot is the APs and the controllers ship in compatibility mode sometimes, although we've started changing that on the zone directors to be shipping in performance mode. Performance mode will open up all of the 5 gig channels to allow you to use both standard and DFS channels.
So Next AV is asking, how do you fight the DFS channels giving you false positives?
So in our world, because we use our technologies, that we actually use Channelfly. Channelfly will look at the different channels for DFS channels, and if it will go through. Right now we have it set, instead of 20 seconds, it's going to do it every 5 minutes. It's going to look at the channel and then go and switch that channel to the next channel that performs better than the last. So that's how we're able to do it. It's all done through software. You don't have to think about it. It's doing it for you.
Is that a type of AI built into the device?
It is. It is. It's actually called Channelfly.
Cool. Todd would like to know, what are some of the best tools for validation surveys?
That's a great question. I'm gonna refer this back to Nathan because I'm on his team, and we are testing several different tools right now, and I don't want to let the cat out of the bag quite yet.
So there's well, there's 2 different ways of looking at this. So if you're looking for purely validating the RF environment, a lot of it's based on the budget and the time that you want to dedicate to providing that. Metagate has a lot of tools for entry level, getting into the environment, starting to become more familiar with not only being able to analyze what products are producing Wi-Fi in the environment, but what transient RF exists in the environment. And you're as strong as the tools you use. So as you get into wanting more accurate and more predictive results and being able to do full site surveys, then you're going to use site survey hardware. We currently use Ekahau. We've also looked at NetAlly and some others, but there are different professionally based site survey software applications that then leverage a variety of different RF adapters. Either way, from a true RF perspective, the best tools that you can afford are definitely worth using, and at a minimum, MetaGeek I think is a great starting point. Secondly, when you're walking the environment, and remember what Bobby said, you're going to walk the environment like a homeowner would do to verify that their coverage is going to work as expected. So you want to walk where a homeowner is going to walk, sit where a homeowner is going to sit, and use something that's very sensitive to poor roaming. So something like a Twitch stream video or Wi-Fi calling. And if you can utilize these applications that are sensitive in the walk path that a homeowner is going to use, you can generally anticipate that they're going to have good experiences as well.
Awesome.
Thank you, Nathan.
So another question for you. Michael would like to know if the A750 is the go-to access point if their client is willing to spend the money.
Michael, I'm going to say yes every single day. Yes. If you want the best performing access point that we provide, the A750 is going to be your AP.
You're getting the thumbs up. That's awesome. All right, so those are all of the questions so far, unless anyone else wants to drop something in the chat box.
Wow, I can't believe I covered everything. No one has any other questions.
You did good.
Yeah, that was great. Oh,
there we go.
How important is backhaul on an AP for the future?
I'm going to let you answer this, Nathan, because I will laugh the entire time giving this answer.
So let's start this off with Wi-Fi is always a technology of convenience, not performance. So when determining the amount of throughput that an AP is going to be able to utilize for transmission of data, it's backhaul. The proper way to do this, especially from a design perspective, is to always utilize a wired backhaul. And the wiring doesn't have to be more than 5E or 6, because you can put it on an N-base-T switch, which is capable of doing 2.5 gig, things like that. But either way, wired access points are absolutely your design go-to. There is never a reason you can't run a wire. You just may choose not to because of budget, but there's never a reason not to. If you have chosen to not run a wire, or you've made a mistake and you're having to fill in coverage by adding an AP via mesh, which is generally the reason why you would add an AP via mesh, then it's very important to look at which APs you're using. A mesh backhaul is only going to be as powerful as the APs that are being used. So if you've got a 550 AP that's being used that's capable of a 2x2 backhaul, if it's Wi-Fi 6, and then its maximum connection on 5 gig is going to be 1.2 gig on an 80 meg channel. If it's connecting on 2.4, obviously its maximum is much lower than that. It's 273, and your throughput's going to be about a third of that. So you're probably going to want to upgrade to a 650 or a 750 to ensure that the backhaul in a mesh scenario like that is as high as possible, to ensure that you don't have any data rate limitations due to bottlenecking on that backhaul link.
John would like to know if you guys have any thoughts on buffer bloat in current networking. That's a new one for me too, so I'd like to know.
So well, let me real quick, Todd responded quick on, what's your speed of backhaul in the AP? Let me finish that since he kind of followed up on the question. Any access point needs to be able to do a minimum of 1 gig connectivity right now. And even later on, even at a 1 point with 80 megahertz wide channels, a maximum connection of 1.2 gig channels on most devices, you're really only going to see about 400 to 500 meg throughput. So you should be fine with regular 5E or 6 cabling. I always recommend wiring every AP location with 6 and 6A. So if you need to go to 10 gig or you need a second connection or anything like that, you can. Additionally, by doing different switch hardware, like I said, you can go to 2.5 gig. If I'm using an access point like an R850 or something, which is designed from the beginning to use 2.5 gig, I will absolutely connect it to a 2.5 gig switch from the beginning. So there you go. Answering the buffer bloat. One of the biggest things we find in networking is people forget that your network is the most critical the system that you are going to put into a house. Every single thing you do in that house depends on the network. It is the one system that you cannot cut corners on, period, because it will only affect your profitability if you do. You will absolutely lose all profit if you cut your network, because you're going to deal with problems here, there, whatever. Buffer bloat in any type of application where you're reaching a buffering status means you've got to really consider, what are you doing on the network that is causing you to have an issue and a concern. I don't face that on any of the networks that I've designed or done, because we don't have issues where we run into bottleneck. We don't run into issues where we're oversaturating or over exceeding capacity on things. And even when it comes to wireless coverage, if you're dealing with consumer and prosumer APs that can only handle 20, 25 concurrent conversations, sure, you're gonna have issues. We have APs that can handle up to 1,000 concurrent conversations. So the idea is utilizing hardware that can handle fluctuations of traffic and traffic types, and then ensuring you don't deviate from best practice design.
That's a great question. That was a great answer to that great question, for sure.
All right, it looks like that's all we have.
All right, guys. And again, thank you so much for sticking around. This was great. If you have anyone that's on here that wants more training, Nathan Holmes is here. He's our director of training. Thank you, Nathan, for joining in. He is the person that will help produce and provide these kind of trainings. I'm part of his team, so we're always here for you, as I said before. So I want to thank everyone again for stopping in, and hopefully you learned something new, or you can actually enhance some of the knowledge that you already have. So if there's any other questions, please feel free to hit us up. We're here for you guys anytime, any day. We're always there. Keeping you connected, right, guys?
Thanks, everybody. I appreciate you being here, and I appreciate your support of Bobby and our team.
Thank you, guys. Take care. Bye-bye.